Assalamu alaikum. So today we are going to be talking about a slightly easier topik, which is parsing. And I'm not going to go into a lot of detail of parsing, but I'll give you an overview of what happens. Okay, you must have covered a lot of it in Automata or in some other course. ठीक है, तो I'm going to be talking about parsing and POS tagging. That bit I'm going to go in a bit of detail and probably show you a notebook of how to use POS tags given some sentences or a corpus. ठीक है, तो let me share my screen. अच्छा जी. तो as I said, today we are going to be talking about parsing. Okay. So what is parsing? It's actually converting a sentence into its structure. So giving structure, a grammatical structure to the sentence. So you need a grammar. So given a grammar in CFG format, which is the context-free grammar, we want to generate parse trees for a given sentence. Okay. So the idea or the purpose behind generating these parse trees is to do grammar checking. And also these trees can be further used as features for sentences when you're processing them in natural language. Okay. So again, the first purpose and the main purpose is to check for grammar. And that's what you've been doing in Automata for or in some other course for programming languages. Okay. So let's take an example. I'll show this with an example. So let's say we have a sentence in Urdu saying ke Changiz, this is a Changiz Khan Mongol tha. ठीक है? And I want to generate the possible one possible parse tree at least that's correct. So for this I need a grammar. So let's say I have a mini CFG for Urdu, and this is what it is. So for the start, I have the sentence, which can be a verb phrase and a noun phrase, and I'm going from left to right. So let's make it that way. Then a noun phrase, NP, can be another noun phrase or a noun, and then a noun phrase, just to add some ambiguity, can just be a noun. And these nouns, I have, let's say, a limited set of nouns that I'm describing. Let's say Changiz and Khan and Halaku and Mongol. Let's say even Mongol is a noun. Okay. Then we have verb phrases, because we need to define a sentence as a noun phrase and a verb phrase. So we have verb phrases. Let's say for simplicity's sake, a verb phrase is only a verb. Okay. And verb can be tha or hai. Okay. So let's say this is the entire grammar that I have. So what I would go about doing is start with the starting token, which is S. Okay. So I'll start with an, let me use the same color. So I'll start with an S, okay, which is the sentence, and it can only be a verb phrase and a noun phrase. ठीक हो गया? So simple things first. let's say verb phrase is less ambiguous, so I'll go with the verb phrase because there is only one definition for the verb phrase. Verb phrase can be a verb, and a verb can be tha or hai. And in this sentence, we have tha, so let's say tha. And then I'll use the blue color. Okay? Tha. So we have mapped the verb phrase. Now, the more ambiguous part, which is the noun phrase. A noun phrase can be a noun phrase and a noun, or just a noun. So, since we have a compound noun, so we are going to use the first definition, a noun phrase and a noun. Okay? And once we have a noun, and that's on the right hand, the most right hand side, I'm going to go with the noun and say, okay, a noun can be one of these. So I'll pick, okay, bhai, Changiz. Okay. Now I have this noun phrase remaining. In between, I have Khan and Mongol. So I'll go with the noun phrase and a noun. Okay. Now, once I have this noun, then I can say, okay, bhai, this in this location would be Khan, Changiz Khan. And the way you read this sentence is from left to right. So a noun phrase here in this case, the only thing remaining is Mongol. So I would pick this rule in the grammar and say, okay, in this case, a noun phrase would just be a noun which would just become Mongol. Okay? So now I have the complete parse tree. The sentence can be read this way, in this direction. So from this direction to this to this. Okay? So Changiz Khan, Mongol tha, and I have the complete parse tree. Acha, so I'm missing out some of the details in generating this parse tree. The method used here is called top-down parsing. And the idea is to start with the root node and build the tree from the root to the leaves, and the sentence should form at the bottom at the leaves, and it should be correctly formed, and there should be a correct parse tree. ठीक है. So that's what we are seeing here. The algorithm is slightly more complicated in the sense that it will get into dead ends, and it's going to back off and try new trees, and it can also generate multiple trees. So that's also a part of parsing. But that's not the idea here. I just wanted to show you okay, a parse tree can be generated in this way. This is top-down parsing from the root node all the way to the leaf nodes, which represent the words in the sentence. Okay? So the second strategy, continuing with parsing continued. There, the second strategy of parsing can be called or is called bottom-up parsing. Say, in this, we begin with the words as input to the parser, and it builds up the tree from the bottom, from the words. Okay. So I'm going to show you the same using the same example. Let's say the example that we had was Changiz Khan Mongol Tha. Okay. So remember the grammar that we have or we had. Let's see if I can cut it. Select rectangle, Control C, and let's go. Aha, it's a good idea. So now I have the grammar here. See? So this was the grammar. Now I want to build the parse tree bottom up. See? So I know that Changiz is a noun from here, Khan is a noun, Mongol is a noun, and Tha is a verb. Now, verb again is the simpler piece here because it's non-ambiguous. It goes this way, so we are going backwards in deriving this. So verb can be only a part of the verb phrase, and then verb phrase would be a part of the sentence, which we do not have as of yet. So let's pick up something else. We have a noun, and the noun can be just a noun phrase, or it can be part of the noun and noun phrase. Okay? So how are we going to do this? Let's say and there is science to this. Let's say we pick this rule, and say that this is a noun phrase. So we can combine these two in a noun phrase. Let me leave some space up here. So a noun phrase and a noun, and we have Khan and Mongol connected. Now I can have another noun phrase which can have this noun phrase and this noun. So we have now Changiz Khan Mongol connected in a correct parse tree. Okay? And then we have these two roots of the subtrees, which is verb phrase and noun phrase. So I can combine them as noun phrase and verb phrase. Okay? So this forms the same parse tree, except that in this case we have gone bottom up instead of top down. Okay? So that's parsing. In short, we want to generate these parse trees for sentences to see if they comply with or they are in accordance with a grammar. Right? So that's parsing. Now let's move on to parts of speech tagging, or in short, known as POS tagging. So, what's parts of speech tagging? It's the categorization of words into classes, into parts of speech. Okay? So, categorization of words into grammatical classes. So, these word classes are in English, for example, nouns, verbs, propositions, adjectives, etc., adverbs, and so forth. And there's subclasses of nouns, कि there are proper nouns and common nouns and so forth. ठीक है? So, in general, there are 8 core POS tags or 8 core POS classes. I'm going to dwell into this a bit more because POS tags are generally used for classification, for further downstream classification tasks, as well as many other tasks. सही है? You can imagine if you are generating text, you might need to figure out that you are generating correct sentences in the correct class categorization of words in sequences. ठीक है? So you have nouns as the first class, and these are labeled as an N, see, in as a POS tag. So tagging is you're given a sentence, you're tagging the words. So nouns are, for example, Pakistan, India, and names are nouns. Class is a noun, though it's a common noun. Cat is a noun, and so forth. Right? So that's a first class, names and concrete objects. The second class is verbs, also tagged as VB. So you have see, eat, live, etc. are all verbs. These are action words. Then you have adjectives describing some noun and tagged as JJ. You have old and you have superlative forms, uh, odd, let's say, older, oldest. See? So these are noun or pronoun descriptors. See? Or and then there are adverbs, which are verb descriptors, and labeled or tagged as RB, such as slowly, walked slowly or walks slowly, talks softly, etc. are adverbs. So yeah. So then there are others such as preposition. Yeah, preposition written as in, joining words such as to, with, and such. Then there are conjunctions, joining two pieces of monolithic semantic phrases. So CC is the tag, and conjunctions are and, or, but, and so forth. Okay. Then there are pronouns. PRP is the tag, and pronouns are uh, he, she, it. Right? These are noun substitutes, they substitute nouns. Then there are interjections tagged as UH, such as alas, and you would use exclamation marks, O, say, hello, and so forth. See? So these are mostly emotion words. Okay? There are two types. These can be further subdivided into more POS tags. And in the English language, there are all these subdivisions combined. There are 52 parts of speech tags. Okay? So I've written these major 8 classes in different colors. So these 4 classes are open classes and these are closed classes. So open classes include nouns, verbs, that, for example, nouns, new nouns can be added. These, the set comprising of all the nouns is not finite. See? And same thing goes for adjectives, adverbs. New things keep popping up and being added to things. Generally in languages, these classes of propositions and pronouns, these are closed. This is a closed set, and new words are generally not added for long periods of time in these classes. See? So coming on to the applications of POS tagging, what can you do once you have tagged corpus or subset of sentences with their respective POS tags? One application is disambiguation. That is, we have words that are used in the same word being used in a different context as a noun or as a verb, and that changes the meaning. For example, book is generally a noun, but book can be used for booking a flight, booking a ticket, and so forth. So this can distinguish between homonyms as well. See? So can distinguish between homonyms. two words that are actually different, but they are they're spelled and pronounced the same. See, for example, let's say okay, I'm doing some translation and I have this weird sentence: we fish for fish. Right? So if I were to just translate it literally, what would this become in Urdu? Right? Let's say machine translation, we would become hum, and let me write it this way: hum, machli, fish, for, तो कर लिया के लिए, and fish, मछली. सही. So what would this sound like? This हम मछली के लिए मछली, and in English it says we fish for fish. So we know okay, bhai, we have this preposition. If we had tagged this, we have this fish as a verb for an interjection, or sorry, preposition. उल्टा हो गया. We is a pronoun. सही है. This is a preposition, and this fish is used as noun. So the thing is, once we have, if we have tagged this, we can do a better translation. Okay, we know okay, these two things, this fish is not the same as this, because in one case it's being used as a verb and the other case it's being used as a noun. ठीक है. तो that's one. Another application is named entity recognition. And this is a simpler one. In this case, in named entity recognition, we are trying to figure out nouns and classifying them as uh, persons, location, and organizations. So, yeah, identification of nouns as person, location, organization. Okay. So this is an important task in NLP, such as, let's say, I'll give you a sample sentence. Imran was born in Lahore and studied at Oxford. So yeah. Now we have these proper nouns. We have Imran, we have Lahore, we have Oxford. Now in named entity recognition task, we are trying to figure out okay, this is a person, this Lahore is a location, this Oxford is an organization or a university, or and it's not that clear, because Oxford may be classified as a location as well. Then another application that we are interested in quite a bit is speech processing, because when we are converting samples from, let's say, we are doing speech synthesis, and we are translating, or we are converting from text to speech. So we are basically generating speech. Okay? And the words sometimes, for example, are pronounced in or written in the same way. For example, lead, or led. Okay? And is this being used as a verb phrase, or a verb? I should say verb, or it's used as a noun. Say it's important to see how they are being used. So if we have text, we have this labeled as with the parts of speech. We can probably make a better synthesizer of speech. Okay? So all of this tells us that there is a lot of ambiguity in language, and we are trying to resolve this using this part of speech tagger. Okay? The thing is, almost 40% of all tokens are ambiguous. in any given language. And that's the beauty of language. That means in this case, 40% of all tokens have multiple meanings. Not only that, they can also have multiple tags. Multiple POS tags can be assigned to these tokens. So if you look at the dictionary or the thesaurus, you will see there are words. There's the same word, also put down as a noun, also put down as a verb, also put down as an adjective, and you can see where the ambiguity lies. See, and let me just give you a small example. Let's say I have the word back. So the word back can be taken, and let me give you concrete examples from the newspaper. So the Pakistani economy today, let's say, took a back seat. Another example can be the building in the back. Say that's the back side. So how about senators? Senators backing the bill. Back the bill. See, I have your back, or he began to back towards the door. Perhaps we are talking about a car here, and it's ambiguous. And finally, my favorite, I was 21 back then. See? So multiple uses of back. So how would you assign a POS tag to this back? You would go and look at the context and say, okay, bhai, acha. In this case, the POS tag is an adjective. This is a back seat. It's describing this seat. How about the building in the back? And here, back is being used as a noun. Senators back the bill. Here, it's being used as a verb. He began to back towards the door. So that's used as a verb. I was 21 back then. So it's being used as an adverb here. See? So multiple tags can be used for the same word depending on how the word is being used. Okay? So that's it for the lecture today. But I'm going to share a notebook. Let me do the notebook with you. So let me open the notebook. Okay. Okay, so I have the notebook open, but let me share that notebook with you. Stop presenting, have a tab. Okay, so one thing that you can do is try this out with me, and we'll see what we can do. I'm just going to play with the POS tags of NLTK. So I'll import NLTK, and let's say from NLTK dot tokenize, I import word tokenize. Right? So here I'm just importing the tokenizer. So what does that do? Let's say I have a piece of text and I pass it to word tokenize. And for the exams, we shall wait. ठीक है, मुझे पता है आप लोगों के दिल की आवाज. तो NLTK. So let's print this list. तो you see कि उसने tokenize कर दिया है. Now we have NLTK POS tagger. NLTK dot POS tagger. It takes the list of words and hopefully correct sequence and tries to tag it. So I'm going to give it this list text, and you see it has made it has given tags to each one of the words in the sentence. So it's pretty impressive. It classifies and as a conjunction, and exams as noun, we as a pronoun, and wait as a verb. So that's pretty good. ठीक है. So let's try this on another sentence. Let's say I have text 2 and I do word tokenize, and let's put down some interesting sentence. They refuse to study let me make some errors. स्टडी छोटा वाला स्टडी लिख दे जिस तरह आप लोग अपने मैसेजेस में लिखते हैं. ऑनलाइन because of the THE their I'll सही लिख देता हूँ their learning progress. थोड़ा लंबा sentence. And then let's give it to the POS tagger of NLTK, POS tag of text2, and you see कि हमने स्टडी को जान के गलत लिखा था, लेकिन it has still classified it as a verb because because of the way it's being used in the sentence. So it says कि भाई this is a verb, although we have not even pronounced it, or we have not even spelled it correctly. ठीक है. Let's try some other interesting things that might be useful for your later projects. So I'll take the text and use the NLTK text object to lowercase the words, word dot lower for word in NLTK dot brown corpus जो मैंने शुरू में इंट्रोड्यूस करवाई थी. brown NLTK dot corpus dot brown dot words. सारे words brown corpus के लिए. Let's see if it finds them. It might take a bit of time. That was fast. And then from this corpus, let's try to find, and this is where we are going to be headed after Eid, is we take this text and find similar words to, let's say, girl, and let's see if it can find similar words and what kind of words does it give us. So it says man, way, boy, day, time. But you see, most of these are nouns. That's good. So there is something going on in this similar method, although uh, it gets some of these wrong. Not clearly the kind of words we had in mind, but it gets them right in the sense of the POS. So let's try something else. So text dot similar says war. So let's see war. Finds it turns out it finds some of the same words that it had earlier because it's mainly doing similarity checks based on the use of these words and mostly POS tags. See? So how about these NLTK dot corpus dot brown dot tagged words. So many of these corpora within the NLTK and especially the brown corpus is heavily annotated. So it's labeled. So you have words. For example, it's giving you the deeper labels of these words in the brown corpus. So let's dig slight bit deeper into the brown corpus. So from NLTK dot corpus import brown. As I said, this corpus was developed although in the 90s, but it is heavily labeled and good for playing around with. Okay? So there are some news articles in the brown corpus. Let's take those articles from the news category. So let's say let me create a variable brown news. That looks a bit racist. Tagged. So brown dot tagged words, and I want categories GUIS, category of news, and the tag set universal. That's a 52 tag tags. Okay. So tag frequency distribution of these tags, let's say. So NLTK dot frequency distribution over the tags. So I want the frequency distribution for all the POS tags that are in this news corpus. So figuring out how often do journalists write nouns or verbs and so forth. So for that, I would do tag for word comma tag in brown news tagged. Oops, print नहीं किया. So let's print the tag frequency distribution most common. Okay. So that tells me that nouns are heavily used, 30,000 as compared to verbs. तो verbs are only 14,000. इसका मतलब है जर्नलिस्ट काफ़ी गीबत करते हैं कितने लोगों के नाम लिख के उन्हें बुरा भला कहते हैं, उनका कच्चा चिट्टा खोलते हैं. और as you can see कि the other tags, determinants, adjectives, adverbs और ये वो वाले POS टैग्स नहीं दिखा रहा जो मैंने बनाए हुए थे. तो एनीवे, लेट्स सी. Tag sentences. Let's do something else. So, what if you are building your own tagger? You can still use NLTK. For example, if you're doing it for Urdu. So, let me give some raw text. This can be in Urdu. Let me. ताकि आप लोग ये ना कहें कि हमें उर्दू में नहीं सिखाया जाता. अच्छा जी. तो लेट्स से यू हैव दिस रॉ टेक्स्ट. कैसा जबरदस्त टेक्स्ट पकड़ा है. इसमें लिखा गर्दिशी कर्जे में कमी का हदफ का हुसूल मादूम होने लगा. गर्दिशी कर्जे आपको पता होना चाहिए कि दीज आर सर्कुलर डेट्स. ठीक है. तो लेट्स से कि हम इस रॉ टेक्स्ट को टोकन्स में कन्वर्ट करते हैं. टोकनाइजर यहाँ पे स्पेसेस की बेसिस पे कर रहा है. तो वर्ड, लेट्स होप कि works. Tokenize raw text and let's spread the tokens. aha, good. तो टोकनाइज कर लिया हमने. उसके बाद लेट्स से कि वी फर्स्ट यूज द डिफॉल्ट टैगर NLTK dot default टैगर. वो सिर्फ इनिशियलाइज ही करेगा. और लेट सपोज कि मैं सारे के सारे वर्ड्स को नाउन बना देता हूँ. यहाँ पे गर्दिशी कर्जे में कमी का हदफ उसूल मादूम. ज़्यादा नाउन्स ही होते हैं. तो डिफॉल्ट टैगर डॉट टैग all the tokens that we have. हमने देखा कि डिफॉल्ट टैगर ने क्या किया कि उसको टैग कर लिया. देन यू कैन ऑल्सो बिल्ड एन एवेल्युएटर. जो आपके पास ज़्यादा बड़ा डेटा हो, उसे आपने हैंड टैग किया हुआ हो या पहले से टैग हुआ हो. यू कैन हैव द इवैल्यूएटर. चलेगा तो नहीं उर्दू पे, लेकिन लेट्स से कि डिफॉल्ट टैगर जो मैंने बनाया है, let's call evaluate और ब्राउन. ये तो बहुत ही कोई गलत काम करेंगे, लेकिन चलो ब्राउन टैग्ड ब्राउन न्यूज टैग थी मेरे पास. आउच, सही एरर है. क्या कह रहे हैं? हाँ, अनपैक करने को ऑब्वियसली वो सारा इंग्लिश में. तो एनीवे, you can evaluate it if you have some other टैगर जो आपने टैग किए हुए हों बड़ी कॉर्पस से, उसके साथ इवैल्यूएट करेगा और आपको कहेगा कि इतने सही इतने गलत. लेकिन इसके अंदर यहाँ पे हमारे पास है नहीं कुछ. इंग्लिश में कर लेते हैं. अगर मैं इंग्लिश में कर लूँ तो क्या होगा? I happen to have a new sentence. सही है. So this is the second row, new tokens. Second row tokenize करा उसे. डिफॉल्ट टैगर लगाते हैं इसे. और टैग कर लेते हैं tokens. These are tokens 2. default tagger, let's say verb बनाते हैं, and then I want to evaluate based on brown, कहाँ गया, brown news tagged. Oh, still. यानी कि कुछ और भी मसला है। तो ऐसा करते हैं कि नए सेंटेंसेस बनाते हैं फ्रॉम न्यूज़। तो ब्राउन टैग्ड सेंटेंसेस निकाल लेते हैं, दैट वुड बी इक्वल टू brown dot tagged sentences, categories news, और फिर हमने टैग्ड पूरे सेंटेंसेस। ओके, हाँ चला, यानी कि ये दिखा रहा है कि ये आपकी एक्यूरेसी है। इफ़ यू जस्ट डू अ रॉ वर्ब वाइज टोकनाइजेशन, उर्दू में तो वैसे भी नहीं चलना था इसलिए कि वो वर्ड्स उससे मिलते ही नहीं, लेकिन मैंने यहाँ पे एक छोटा सा सेंटेंस दिया है। इससे मैंने सारे वर्ड्स को वर्ब असाइन कर दिया एज अ डिफॉल्ट टैग, और फिर फिगर आउट करने की कोशिश की फ्रॉम अ लार्ज टैग्ड डेटा सेट ऑफ ब्राउन सेंटेंसेस, यानी फ्रॉम द ब्राउन कॉर्पस, टू सी कि भाई कितनी एक्यूरेसी है मेरे इस डिफॉल्ट टैग की, एंड देन वी कैन अपडेट। तो इसको ऐसे नाउन करके देख लेते हैं, नाउन्स शायद ज़्यादा होते हैं और इसमें हैपन टू हैव, हाँ थोड़ा सा बेहतर हो गया। लेकिन again you can use this kind of a strategy to build a POS tagger for Urdu। मैं देखने की कोशिश कर रहा था, मुझे तो नहीं मिला वैसे उर्दू हैक में। शायद किसी ने POS टैगर, नहीं POS टैगर तो शायद POS टैगर बना हुआ है। हाँ, मैं पार्सर देखने की कोशिश कर रहा था, पार्सर मुझे नहीं मिला। So I'm going to upload this file as well, and I would like you to type in as I go along. लेकिन if you haven't, then at least run this for a bit. ठीक है? चलें, I guess that's it, and thank you very much. I'll take any questions from here.